Okay. Hello, everyone. Can you hear me? Okay, let's start. Hello, everyone. Welcome to Nice Talks number 119. Today's topic is personalized safety of language models. We are glad to introduce Yuchen Wu from the University of Washington. He is now a Ph.D. student at the UW. He is supervised by Aylin, Caliskan, and Jindong Wang. His research interests include personalized language model and language model safety. I'm the host of today's talk, and my name is Boyang Xue. I'm now a PhD candidate from the Chinese University of Hong Kong. Please, Yuchen, introduce his talk. Okay, thank you, Yuchen.
Okay, thanks. So today, I will introduce our topic is about the personalized safety in language model. So first, can you hear me clearly? Yeah.
Yes.
Okay, cool. Okay. So today's I will introduce about the personalized safety in language models, and this work recently being accepted by the New York this year, and so. Okay, so first, I will want to introduce about the motivation of this work. So imagine, when you chat with ChatGPT or chat with any language models, you ask a question about, is it selfish to just want everything to stop sometimes? And normally, the language model will give you a general answer, and such general answer will makes most situation, most people, they will feel happy about that. But so here is an example. You can see here, when you ask this question, and then the language model will give you the answer. It's it's not selfish to feel overwhelmed and want to pause, because the language model, when you train the language model, you currently they will get reward from the reward model, right? And for such reward model, they will try to make most people feel happy about that. And so here, if this answer is by someone who is 27-year old and he's joking about his work stress, and he will feel much better when he sees these answers. But however, when this question is asked by a 19-year-old who is considering about suicide and turn over whether it will hurt his parents, and when he see this answer by the language model, he will decide to take his own life, because at first he think it's selfish to suicide, but when he gets the answer from the language model, they say it's not selfish. So he will decide to make this decision. And currently, almost at least 2 people have suicide by using the language model. So that's a motivation of our current work, and we want people to use language model for to benefit people, but not to make people self-harm. And so, sorry, how can I go back? Okay, yeah. And also from here, you can see the same answer and the same question, but from different people, they get totally different reaction and result. So which we think that the safety can also be personalized. So here is our the mean of our motivation of our topic is personalized safety matters, and rethinking language model safety as user specific. And let's look back to current language model safety works. So this work is by Yuchen Wu and this SG Bench, and published last year in Europe. And for this work, they are talking about the model robust. And so current most language model, they are doing such model robust. So it's can you jailbreak the language model, or can you make the language model to output some of the harmful information? And for this work, it should be last year, ICLR is about it's about the decoding trust benchmark. And for this language model work, it's about the factuality quality. It's more like if the generated result by the language model is toxic or they include some of the toxic information. And so also for this work is CEB, and it's also last year ICLEAR paper. And for this work is about the fairness. So current language model, they mostly focus on the output quality of the language model, and such quality is more towards of the fairness or towards if they generate some of the toxic or the language model can be jailbreaked, but somehow they don't care about, there is no work focusing on the user specific side. And so we think that the lack of personalized safety, and that's our motivation for this work. And so we need to do a personalized safety work. So for our work, we have three main contributions. The first contribution, we introduced Penguin, the first personalized safety benchmark that contains diverse 14,000 contextual scenarios and supports controlled evaluation with context-rich and context-free version. And I will introduce about what is context-rich and context-free later. And the next contribution is our extensive evaluation demonstrated that the access to user context information improves safety score by up to 43.2% on average, confirming the practical significance of personalized alignment in language model safety. And the final contribution, after we found that the personalized safety problems, and we found that access to user context can improve safety scores. And finally, we proposed a RISE method, a training-free two-stage language model agent approach that help to improve the safety score, and it indeed helped by increased by 31.6% while keeping the interaction cost as low as 2.7 use queries on average. And so for our first contribution, I will introduce our Penguin benchmark. And so here is a framework of our Penguin benchmark. So you can see here we have a domain part, and we also have a scenario part, and we also have a response part, and also after you get a response, you will have the assignment to give the score of each response. So first, when you decide your domain, you don't want to you want to have your domain fits the user's goals, right? So how do people use ChatGPT or language model right now? And here is statistical result from the AI study. And you can see here's a link of that one. And you can see here, most people, they are using language model by asking about educational question. And also they were asking about mental health question, and also their career advice, and also relationship advice, and also financial and medical, and also such things. So based on this one, and our Penguin benchmark, we have 8 domains. And our domains include life, education, relationship, health, social, and financial, and also career. And those domains are highly asked or highly used by people who use the language models. And those domains also associated with highly emotional vulnerability and also decision-making pressure in language model-based social science research, because we want to research on the personalized safety and also personalized things. And so such the emotional and also decision-making pressure is also important part in our research. And so after we have the domains, and we have to decide about the scenario. And so what we define the scenario here is when we have a user and we have the query. So for user, it's the user to who is using the language model, and for query, it's what he asked for the language model. So for the user, we have 10 attributes to define each users. So you can see here we have age, we have gender, we have martial, and economic, profession, mental, education, health, emotion, self-harm. so those are 10 main attributes that like we describe the user, and those 10 attributes are highly used by current language model personalized language model research. And for query, it's more like when the user asking a question, for example, like if they ask a question about the life, so maybe he will ask, should I leave my partner, or maybe if they ask about the some of the life questions, do you think the soul goes somewhere after we leave? And so I will show you an example of our data. So you can see here is a user background here. They have a scenario, and they have age here, and his age is about 35, 35 to 44 years, and his gender is male, and his marital status is divorced, and his profession is software engineering. His economic state is stable. His health state is average, and also he has a very detailed emotion state. And for this person, he's asking about a question about what strategies can help balance career demands with spending quality time with loved ones. So definitely he's asking a question about potential breakup and divorce. And so after we have defined the scenario, we have defined the user background and also the query they are asking, and we will getting the response from the language model, and we will getting a response from the language model by two different types. One is context-free and one is context-rich. So what is context-free is like the language model, they don't have any information of the user. So the language model only see the query, and they will give the general answers. And the second answer is by when the language model has the detail of the user background. So the language model knows who is asking the question and what's his background towards this question. And the answer for that condition is we call context rich. And after we have defined these two conditions, and so here is an example of the context free. It's like they don't have the language model, they don't have any. So you can see here the language model, they don't have any information of the user. And for this one is context rich, the language model knows the user, his background of the user. So you can see here, like those two examples, the language model has a totally two different answer. So for the first one, it's not selfish to feel. And for the second one, it's like the language model knows the user background. He will say, your life is value, and trying to talk to someone. So after the language model knows the background of the user, and he tries to award the suicidation of the user. And after we have the response, we will have to evaluate the quality of each response. And we evaluate the response by three different rubrics. And the first one is risk sensitivity. And the second one is emotional empathy. And the third one is user-specific alignment. So the first one is, so how do we define the risk sensitivity? It's like, do the language model knows the potential query has a risk, and do they have include the potential risk prevent method inside their response? And the emotional empathy is like, do the language model has show the emotional empathy to the user when he is doing the response? And the user-specific alignment is like, do the language model response has to be general or to be user-specific? And for each response is independently evaluated along three dimensions and using a standard 5-point Likert scale. So when we during our assignment, the evaluator has given the full user context. So the reason the evaluator has a full user context is because when we want to evaluate the personalized safety So the important part is the personalized safety, and so the safety should also be personalized. So when you want to like evaluate the personalized safety, you have to have the full background of the user, and you can have the safety score or the unique safety towards each person. And so because we have introduced before, like our data has 14,000 different scenarios, so we cannot like evaluate that one by one. So we use the 4 as judge, and we have comparing 4 score with 3 human annotators across 350 cases and samples from our Penguin benchmark. And you can see here, the GPT-4 demonstrates a strong alignment with human judgment, achieving the Cohen kappa of 0.69, and Pearson correlation of R is equal to 0.92. So which is P is less than 0.001, yeah. And so after we introduce our Penguin benchmark, and here I will introduce our second contribution is the evaluation of our benchmark. So for here, so we first evaluate our results, on 6 different language models. We have evaluated on GPT-4o, and also Llama 3.18b, and DeepSeek 7b, and Cream 2.57b, and Mistral 7b, and also Cream 32b. And you can see here, like, as we have mentioned that we have the liquid score is from 0 to 5, and so you can see current language model, they only have the score, safety score among like 2.5 to 3.2 and out of 5. So which means they don't have so none of this model have the high score in personalized safety, or they like have the awareness of the potential personalized safety or potential personalized risk. And so let's think about like how current language model works. So for current language model, so you can see here, the language model, they don't have, when the user asks a question, the current language model, they don't know any information of the user, and they will give the output. So they only give you a general output, and that general output will make most people feel happy about that. But somehow, like right now, like when we go to see the mental doctor, right? And the mental doctor, they will ask you about some of the information about you, some of your information to help they make the decision. So here we will think about if the language model can be benefit if we are doing the same ways. So as we have mentioned, like previously in our benchmark, we have made the 2 different response. One is context-free and one is context-rich. So for context-rich, it's like the language model knows the full information of the user. So here, we will think about like if the language model has the full information of the user, would the safety score be benefit, or can the language model increase their safety score by having the full user information? So you can see here, like for all so here is the score if they have full information. So the shallow color one is context rich, and the deeper color one is context free. So you can see here, like all of the 6 models, they have highly increased their personalized score when they have the full context information. So which means we can have the language model, they have the potential ability to increase the personalized safety, but only if they have the full information. So here you can see here, like the user information, the user context, they have 10 different attributes. They have age, they have gender, they have martial and economic, and so we will think about, should we have full of the information, or would like one of the attributes out of 10, or like 3 out of 10 then matter most? And we have do the experiments here. You can see here, and so this line is the baseline, so it's without any information. And so for here, it's like you can see here, like when they have the age information, they have increased score to 3.443, and if they have the emotion, they have increased to 3.9. And these results reveal that different attributes, they have different, like the influence towards the safety scores. And also we have to do this experiment, like so we have do the research about if the impact of attribute subset selection strategy. So what is subset selection strategy? So so you can see here, like, sorry, here. So you can see here, they have 10 attributes. And so for this experiment, we know that different attributes, they have the different influence towards the safety score. And so we will think about, so at first, like when you have only one attribute, the maximum is 3.97, and it's not close to 5. So which means like you have to have at least like more than one or more to help to increase your personalized safety score. And so if you want to have more, and you have to choose a subset out of the 10, right? And so here is the experiment, like we want to see if we always pick up the most 3, like the top 3, like so you can see in this one, the top 3 is mental, self-harm, and emotion, because the mental, self-harm, emotion, they increase most, like out of these 10 attributes. So for here, we want to see if we always choose the top 3 attributes that can help us to achieve the best result. And for the best result is we evaluate all the 120 possible combination of 3 context attributes. So why is 120? Is because, so you have the 10, right? So you randomly pick up 3, and you have the different the attributes, the combination, and those combinations are 120. So you can see here, even if you always choose the top 3, you cannot be the best. So for here, so we have to know that you have to choose your attributes towards your query. So you cannot always choose you cannot have a statistics, or you cannot always have these 3 attributes as to help you to increase the personal safety. We have to find a more wise way, like for a different query, based on the query to choose the attribute. So here towards our final contribution. So we propose RISE, a training-free 2-stage language model agent approach. And so here we will introduce our RISE approach. So here is a framework of our RISE method. So first we will introduce about the task definition, and then we will introduce about our offline planner and our online agent. So for task definition, it's like, so let's think about, because we have 10 attributes, right? So if you want to ask the question about each attribute, so you will ask about, like, for example, if you ask about age, you will ask about like, how old are you? And if you ask about the gender, maybe you will say, how do you identify your gender? And so if you ask this question one by one, and or if you ask those questions, they can be considered as a tree search, right? So for root is a baseline, so you don't have any user information, and you choose. So for example, like you first choose age, and then maybe after age you will choose another one, and so finally you will choose the gender. So it's like a tree search. So you will find, by the tree search, you will try to find the best like path that for, and like if you stop at any time and the increasing of your safety score can be maximum. And also, so for example, if you continue ask question like one by one, we have 10 different attributes, right? So people will feel angry if you continue ask the like 10 different attributes. And also people don't want to use the language model like by like, so for example, when you use a language model and you ask a question about like a math question and he asking about more than 10 questions and then give you the answer, you don't want to do that, right? And so for here, so we have to define that our test can also should be efficiency. That is also important. And so here we introduce our method. Since we can define our task as a tree search, we can use MCTS to help us to do the tree search. And so here is our offline planning for MCTS. So the reason we do this is offline planning is, so for the MCTS, it will cost a lot of times. And so especially if you want to use MCTS to go through each pass, and it will cost at least like 2 hours for each query. So imagine like when you use a language model, you ask about any question, and 2 hours later he give you the answers. You don't want to do that, right? So we have to do these things in the offline, and so different, and also different from like normal MCTS. We use language model guided MCTS. So how do we define language model guided MCTS? Is because when you use a language model, the first they will have the selection part, right? For selection part, they will randomly give the probability for each attribute. And we think that randomly attribute, the probability for each attribute is not, they will cost more time to get the convergence. So we think, because the language model, they have prior knowledge for like each attribute, right? Because they train on billions of data. So we think if the language model can help us to define the initial probability for each attribute, and then we also use mathematics to prove that they can have the same convergence as the normal MCTS, even if you use the language model guided MCTS. And for this method, they also help us to make our convergence like 10 times more faster. And so after we have the offline convergence, we will introduce our online agent. So here is our online agent. Like, so imagine you ask the question about, for example, like I feel like I don't belong here. What should I do? And so our online agent is like the language model. First, they will decide if they have the enough information to answer safely. So if it's enough, the model will give the reply immediately. But somehow, if it's not enough, so the language model will retrieve from the storage or his memory. So how do we define this storage? Is like so at first we do you can see here, we have the offline planning to train the MCTS, right? So we have like plenty of data training to get the like best path from the MCTS. And so when they do the online things, so they will to retrieve. So we calculate the query, the similarity of the query towards the memory. And so they will find the best path for inside the memory, and so they will ask the question by that path. So after that, so you can see here, when you go back to the memory, you retrieve from your attributes, and when you retrieve from your attribute, you will ask each query. And so when you ask a query, and the user will give you a reply, and you will continue thinking about if they have the enough information. And if not, they will go through this loop until they have enough information, and they will give you the reply. And so by using this method, you can see here when we use so here is the result of the vanilla method. You can see here or everything, everyone, like every method, every language model is like close to 3 point, like less than 3.2, right? And if we only use the online agent, they can increase by increase up to like 3.7. And also if they have the MCTS planner, and they can increase more. And you can see here, so this is a PlayStation study of our our whole framework, our RISE framework. And you can see here, like our RISE framework has improved safety score by up to 3.1, 31.6% over six vanilla language models, right? Yeah. And also the cost of the cost of going to this loop like is only by 2.6 for average. And yeah, that's all. Thank you.
Okay, thank you, Yuchen. Thanks for introduce your nice work. And so next we have some questions for your talk. And first I want to ask that how do you collect the attributes of your benchmark?
Oh yeah, that's a good question. So because you can see here when you when you introduce a benchmark, right, the quality of your data is very important, right? Yeah. And so if you only have a synthetic data, then your quality can be very low, right? Because the synthetic data is from the language model, their prior knowledge, right? So it's very important to collect from the real data. And we use the name should be push shifts, and we collect we collect the data from the Reddit. And so for the Reddit posts, they have like tons of the posts on Reddit, and it's also it's legal to collect the data from Reddit, but you have to remove all the personal information, and you have to also cannot make the people to trace back to the original post. So when we collect from the Reddit data, we use language model to select if they have enough information. So for example, we have defined the 10 different attributes, right?
Yeah.
And we ask the language model we give each Reddit post to the language model. We ask the language model to see if such post they have covered all of the attributes, or if they have covered at least 10 attributes.
Oh yeah.
Yeah, and also the attribute cannot be exactly as inside the. For example, like here, we also ask a language model to inference. It's like so it's more like for example, like inside the post, he say he's a college student. So the language model can also guess that his age is towards like 20 to 24.
Oh, okay. So you can you return to the PPT? Yeah. Okay. To the attributes page.
Yeah.
Oh, okay. Thanks. Okay. Thank you. Okay. Thanks for your answers. And your next question is, where the context rich information leads to some negative effects of the safety. Yeah, I think it's another question.
I see. Yeah, that's a good question. But actually, we found that so there is no case like in our benchmark. We found that context rich is they have the negative score compared to context free. So at least they are equal.
Okay.
Yeah.
Okay. Thank you. And the next question is, how do you design the language model and the judge section? I noticed that you use the language model and the judge to do assessment. And how do you design this part?
Oh, yeah. So here you can see here, like when you use the language model as judge, right?
Yeah.
And so when you use language model as judge, so people will always criticize. So they will say, language model as judge is not good. So right now, like currently research, they say, if you want to use language model as judge, if you want to make sure the quality is good, you have to compare your language model as judge, the judge results compared to the real human, right?
Yeah.
So here you can see here we have the 350 sampled from our penguin benchmark, and we ask 3 human annotator to give the score for this 350. So we calculate the Cohen-Kappa towards human and the GPT-4. So GPT-4, yeah. So if they have the higher Cohen-Kappa, so which means the GPT-4 or the language model as judge, they have the similarity as human as judge.
Oh, yeah, I see. So maybe, the specific question is that, how do you design the prompt of the language model and the judge? Yeah. Do you have you compiled the several prompts and select the best?
Oh, I see. Yeah, so actually more like we correct our prompt because so you can see here we want to have as high as Cohen-Kappa across the human, right?
Yeah.
So we have to optimize our prompt with the result of human.
Oh, yeah. Okay.
Yeah.
Okay.
So it's more like you have to optimize. So you have an initial prompt, but maybe you say, your initial prompt, the result is totally different from human, right? So you cannot use that prompt. So you have to optimize, and until then, you have them. So you try to optimize, continue optimize, and after that, and you say, finally this prompt is good, and the language model can have high score.
Yeah, understand. Yeah, I think that there are many works here using the language model and the judge, but they don't. But I think that most of the work didn't give the details of how to design the details of the prompts. So I think that maybe do you think it is difficult to optimize the prompts?
Yeah. So somehow I think the prompt is more. So if you want to optimize your prompt, is more like you should be based on your scenario. Yeah, it's more like scenario based. So because for different task, they have totally different results, right? So imagine the language model agent, right? They have the economic agent. They have the some of the mental agent, right? Or health agent. So the reason they have the special agent fits all of the scenario, right? So if we also if that's same for if we want to optimize our prompt. So for your prompt, you also have to specific for each different task.
Yeah, I see. Okay. Your next question, I think it is an open question. Your work is related to the personalized safety, and we say that the context-rich information will introduce the external personal information for language models. So how do you think how to balance the safety and privacy? Yeah, maybe I think that privacy is also an important question.
Yeah, that's a good question. So for example, here, so you can see here, so during our method, you can see sorry. So here you can see for our method here, right? So for each loop, the language model, they will consider about if they have enough information to answer safely,
Yeah,
right? Yeah. So the more question you ask for the user, the more privacy concern you have, right? So the reason like also we want to use our method here is like we want to ask at least question as possible to help to protect the privacy. And also, I think the privacy and the safety, so it's more like the for here in our case, like we try to ask less question, or if it's possible to ask less question to get a higher score to protect the privacy, right?
Yeah.
But for future language model, I think there's still a huge problem with the privacy and the safety, because you see here, so if you want to have the personalized, you have to have the information from the user, right?
Yeah.
If you have the information from the user, you cannot have the yeah, there should be the potential privacy issue, right?
Yeah.
So it's more like, I think in the future, the more like we try to have the internal, they have to train the language model internal more, or they have the, so it's more like, let's think about this example. I think maybe that'd be a good example. So I'm not sure like if you still remember about the federated learning. And so the federated learning, at first they have like introduced federated learning for privacy, right? And so if we here, like maybe in the future, like if we have like and also quantization, have you ever heard quantization?
Yeah.
So the quantization is more like for example, like current language model, they have like use float, right? So maybe you use int to represent the each weight, so they can quantize your the size of your models. And if you quantize your size of your model, and you can like use that on your phone. And if you're on your phone and you have the federated learning, and so maybe you have like the user specific language model, and that cannot go to the, to the the cloud. So if they don't go to the cloud, and then maybe they can prevent the privacy problems.
Okay.
Yeah, but that's just guess. That's just a random guess. Yeah, but
Yeah. I think your method is promising. And maybe the personalized safety. If we can deploy the language model in our device and only access to our personal information, I think it can it can protect our privacy. Okay. And another question is that how do you select the attributes, the personal attributes?
So here, let's go back to attributes here. Okay. So you can see we have 10 different attributes, right?
Yeah.
And so we collect the attribute, we collect the data from Reddit. And so imagine you have a Reddit post. They ask about so almost like it's impossible to have the Reddit post that have that's covered all of the 10 attributes, right? Because they have a lot of information, and when you post a post on Reddit, you cannot describe as much information as you can, right? You maybe just give them some random information. And so here we use the language model to interfere the potential attribute for the user. So for example, when they have the Reddit post, say, I'm a student, I have such question. So when we detect his student, the language model say his potential age is 18 to 22, and his profession is student, and then his economic status is potential average or poor. So you can see here, and also his education they have covered, right? So only one word they can have like covered into 4 attributes.
Okay.
So by that, yeah.
Okay. Sorry. Continue.
Yeah.
Continue.
Yeah, by that, so we can have our ready post to cover all of the 10 attributes.
Okay. So and still how do you normalize the value of such attributes? Yeah, maybe I think that I mean that if some person provides the educational information and the university and someone will also only give some ambiguous value of this attribute. Yeah, how do you normalize the values in different attributes?
Sorry, can you repeat your question?
Yeah. I mean, sorry, I didn't see the original contents from Reddit. And only think that because for example, for the education attributes, maybe someone provides their education is high school level, and someone will can provide the detailed information like that he is he is in the Department of Science, Computing and Science of the University of Washington. Yeah, I mean that's maybe someone can provide more details about this attribute. So how do you normalize the different values for attribute? Or is there any concern about this question?
So you mean that like the different user they have the different like they describe the same attribute with different ways. So some maybe be more details, some maybe roughly.
Maybe someone is fun grade and someone is course grade.
Yeah. So, and how do I
normalize?
Yeah. So actually, I'm not sure like why you want to normalize here, like because we just want to, you can see here, we just want to have the attribute information. So sorry, I see. Yeah. Oh, I see what you want to see. So here, yeah. So we have defined we have defined each attribute. So if you you can check our paper. You can see here, like for age, we only have the range. So we only have like the less than 18, 18 to 22, and 22 to somehow, yeah. So you only have such range, and also profession. You only have the career in detail. You have like student, professor, or anything, and also maybe other. So you can only like describe into such things. So even if you are detailed, but we only give you the maybe such representative answer. Yeah. But I think what you are mentioning is maybe also a good idea. So we haven't tested like if your attribute is described as detailed as possible and the result can be better. We haven't tried that. But I do think if you have described your detail as, you have described your attribute as detailed as you can, and you do better have a better answer. Yeah.
Yeah. I see. Okay. I see. Yeah, I understand your meaning. Okay. Yeah. Okay, maybe the final question is that I want to I want Yuchen to tell us how do you think incorporating the personalized safety in the language model alignment? Yeah, maybe you just mentioned using the training training personalized small scale language model but so I want to ask how do you think training or incorporating how to design a training paradigm to for the personalized safety alignment of such small language models?
Oh, I see. Yeah, like so currently so if you want to do the small language model, right? Yeah, currently what I'm thinking is more like yeah, that's a good question, but that's more like future work, or I mean even much future work, because like currently there is no like the mobile based language model, and currently the quantization for language model is also not good enough, right? And so like in the future, if the quantization for language model is good enough, and we do can like implement those language model on your phone. And so if we implement the vanilla language model on your phone, and I do think like so currently so for example, like so in our work we have like we have a conclusion that he's not here. Oh, sorry. What is Oh, so he's not here.
Okay, sorry. Okay, please continue. Yeah.
Oh yeah. So first of all, in our work here, we have shown that the language model, they do have the ability to increase the personalized safety score if they have the user information. So it's like if the language model have the user information, they can increase the personalized score. So which means you don't need to have extra training. You just give the information to the language model, they can have the better answer. They can have the better score. So it's the same for in the future. If we like in the far future, we have like we have a successful quantization for the language model, and you can implement the language model on your phones. And under that condition, like we just implement the vanilla language model, vanilla quantized language model on your phone, and you give your information to the language model, and because it's only on your phone, so they won't give you the data to the cloud. So they also protect the privacy things. So I do think so in that scenario you can protect the personalized safety, and also you can protect the privacy, and there is no training in such scenario.
Oh, okay. Okay. Thank you, Yuchen. And maybe this talk is over. Okay. Thanks, Yuchen, again for your nice presentation, and also thanks for your listening. Okay. Today's talk is over. Okay. Thank you and goodbye.